Let us assume for a moment that you just wrote your first hardware design in a new hardware construction language like Chisel. You also wrote a unit test and it passed. Does that mean your design works? Not necessarily. To check whether your test thoroughly tests the design, we want to have a look at the lines of Chisel code that are exercised by it. Currently, the only way to do this is to generate Verilog from a Chisel design and then use the built-in line coverage of a Verilog simulator. However, line coverage on the generated Verilog is not necessarily the same as line coverage on the original Chisel code, and more advanced metrics like finite state machine coverage are just not supported. Most importantly though, other Chisel simulators like the Treadle interpreter and the FPGA accelerated FireSim do not support any coverage metrics at the moment. We want to support many coverage metrics for Chisel code across all simulators, but we want to do so with a minimal amount of work. We thus propose a new abstraction that allows us to implement various coverage metrics inside the Fertile compiler. All coverage metrics that we implement work on Treadle, FireSim, Verilator, the research simulator Essent, as well as a formal verification tool. Now we can boot Linux on a RISC-V core and get accurate line coverage. Of course, most likely you're not a Chisel developer. However, our technique should be widely applicable to other new and old hardware languages and their simulation ecosystem. All our metrics can be used to implement feedback-directed fuzz testing. If you want to learn more, please check out our paper and artifact and come to our talk on Tuesday morning on session 4A. Thank you!